Hi everyone. Today we're going to be looking at how to solve equations that involve rational functions. So in your notebook, please put today's subtitle, which is Rational Equations. Fortunately, solving rational equations is extremely simple and involves only your algebra skills. So let's get right to it. For our first example, I would like to solve the following. What values of x will cause the rational function 2 over x plus 3 plus 2 to be equal to 5? The first thing we'd like to accomplish is do whatever it takes to isolate the actual fraction. In this example, the only thing we have to do is shift the plus 2 over to the other side of the equal sign, and that will produce a value of 3. Next, the problem here is that although the fraction is isolated, the expression containing the x is currently located in the denominator position. To solve x, we need to get it back into the numerator position. And to accomplish that, we can simply rely on our cross multiplication skills. We want to get the expression containing the x back into the numerator position by cross multiplying with the item on the other side of the equal sign. And that will give us 3 multiplied by x plus 3 is equal to 2. And now we have the expression containing the x back in the numerator position. The only thing left to do is to continue isolating the x. So, continuing with our algebra, this will give us 3x plus 9 equals to 2. Next, 3x will equal to 2 subtract 9, which is negative 7. And finally, x is equal to negative 7 divided by 3, which simply gives us the final result of negative 7 over 3. As you can see, solving a rational equation is not complicated whatsoever. So, let's try another example. Suppose our example is the following. When will the rational function 3 over 2x minus 4 plus 5 be equal to 1? First things first, let's do whatever it takes to isolate the fraction itself. In this example, all we have to do is shift over the plus 5, and that will produce a negative 4. Next, with the fraction isolated, we have to make sure that the expression containing the x goes from the denominator position back into the numerator position. To accomplish this, cross multiplying with the item on the other side of the equal sign is the way to go. So that will produce for us negative 4 multiplied by 2x minus 4 is equal to 3. Continuing with our algebra, we get negative 8x plus 16 is equal to 3. When we keep going, we get negative 8x is equal to 3 subtract 16, which gives us negative 13. And finally, dividing both sides by negative 8 gives us an x value of 13 over 8. I think it's time for you guys to try one on your own. Get this example down. Suppose I'm asking you, when will the rational function 3x plus 1 over 2x minus 2 plus 6 be equal to 2? Go ahead, pause the video, and try it now. Alright, let's see how you guys did. First things first, I'd like to do whatever it takes to isolate the actual fraction. So in this case, all I have to do is shift over the plus 6. And that will produce a negative 4 equal to 3x plus 1 over 2x minus 2. Now, with the fraction isolated, I need to make sure that any expression containing the x located in the denominator position gets moved into the numerator position. In this case, cross multiplying will allow us to multiply the 2x minus 2 by the negative 4. thereby producing negative 4 multiplied by 2x minus 2 being equal to 3x plus 1. And now simple algebra takes over again. Continuing our work, we get negative 8x plus 8 is equal to 3x plus 1. I'm going to move all my x's to the left side. So negative 8x subtract 3x will give us negative 11x. And moving all the constants to the other side, we get 1 subtract 8, which gives us negative 7. And then finally, dividing both sides by negative 11 gives us an x value of 7 over 11. Let's end the lesson with one more example for you to try on your own. Suppose I give you the following. When will the rational expression 4 over 6 multiplied by 2x plus 1 be equal to 0.5? So go ahead, pause the video, and give it a shot. Alright, let's see how you guys did. I think, personally, I'd like to simplify the denominator first. So, using our regular algebra, we get 0.5 is equal to 4 over 12x plus 6. Now, as you can see, the fraction is already isolated, so all I need to do now is make sure that any expression containing the x that is located in the denominator position gets moved back into the numerator position. And our cross multiplying allows us, in this case, to multiply the 12x plus 6 with the 0.5, thereby producing 0.5 times 12x plus 6 being equal to 4. And now simple algebra takes over. Distributing the 0.5, we get 6x plus 3 is equal to 4. Shifting the plus 3 over, we get 6x is equal to 1. And finally, dividing both sides by 6 gives us a final result of x equals 1 over 6. And that's all there is, ladies and gentlemen, to solving equations that involve rational functions. As you can see, it's nothing complicated and simply involves your algebra skills.